Welcome to another episode of Bell the Cat series with Om Bajaj. Today, we will be having a look at one of the interesting problems from the DILR section of the CAT 2024. I'll read out the problem first. So we have a figure below which shows a network with three parallel roads represented by horizontal lines RA, RB, and RC, and another three parallel roads represented by vertical lines V1, V2, and V3. We also have the distance between two adjacent intersections. 6 ATMs are placed at 6 of the 9 road intersections. Each ATM has a distinct integer cash requirement, and the numbers at the end of each line indicate the total cash requirements of all the ATMs on that particular corresponding road. For example, the total cash requirement of the ATMs placed on the line RA will be equal to 22 lakhs. Now, we also have some additional information with us. The minimum and maximum cash requirements are 7 and 15, and they are placed on the same road. Also, the distance of the ATM with the second highest cash requirement and the ATM located at the intersection of RC and V3 is 12 kilometers. This is the intersection of RC and V3. Now let's convert this particular information into a format which we can use. So first, let's rename all the intersection points of these 6 roads with integers. So, for example, the intersection of V1 and RA is A. So, A represents the cash requirement of the intersection of the ATM, which is at the intersection of V1 and RA. So, similarly, V2 and RB, V2 and RA, the ATM at that intersection would be B, so on and so forth. Now, we'll have 6 equations coming out of this particular figure. A plus B plus C would be equal to 22. B plus E plus F would be equal to 20. X plus Y plus Z would be 20. A plus D plus X would be 15. B plus E plus Y would be 21. C plus F plus Z would be 26. Also, 3 of these 9 variables would be 0 because only 6 ATMs are being placed. Also, the minimum and maximum value of these integers of those 6 ATMs would be 7 and 15, and 7 and 15 would be placed on the same line. That's also a given we have. Also, we have given that the second highest cash integer here would be 12 kilometers away from Z, which is at the intersection of V3 and RC. So if we see Y is 7 kilometers from Z. F is 7 and 5. F is 5 kilometers from Z. E is 7 and 5, 12 kilometers from Z. B would be 7 and 8, 15 kilometers from Z. So only E is 12 kilometers from Z. So the second highest variable in this particular set of variables would be E. This is the information that we have. Now let's start with the position of 7 and 15. We know that 7 and 15 are on the same line. So to consider the placement of 7 and 15, we would know that if I place 7 and 15 on line RA, it's a possibility because the sum of RA is 22. So if I place 7 and 15, 22 would be able to suffice that. But if I place 7 and 15 on RB, then the sum of RB is only 20. So I'll not be able to place 7 and 15 on the same line. So there are only 2 lines for which the sum is more than or equal to 22, which is RA and V3. Now, considering RA and V3, let's consider V3 for a minute. So if I place 7 and 15 on V3, then the two variables would amount to 22. So I will be left with 4 as the deficit here. And I cannot make the third variable as 4 because the minimum is 7. That's why I will not be able to place 7 and 15 on line V3. Hence, 7 and 15, the only possibility to place them is on line RA. Now, the variables in array are A, B, and C. So, A, B, and C would have the values between 0, 7, and 15. That's the only possibility that we have. Now, let's look at the placement of 15. If I place 15 at C, then that's a possibility, because if C is equal to 15, then Z plus F would be equal to 11. Z and F, either F equal to would be 11 or Z would be equal to 11, or F or Z sum would be equal to 11. But F plus Z would not be equal to 11, because the minimum should at least be 7. But that's a possibility. If I place 15 at A, then that's also a possibility. In that case, both D and X would be 0, but it's possible. But if I place 15 on letter B, then E or Y has to be 6, because the sum of line on V2 is 21, which is not possible because minimum value is 7. Hence, 15 can only be placed at point A or point C. Okay, now we'll have two scenarios. So for those who are solving along, you can pause the video and solve for each scenario. So C or A would be 15. Now let's go with scenario 1, in which C is equal to 15. So if I place C is equal to 15, then A or B will have to be 7 and the other has to be 0. So if I place 7 and B, in that case, E or Y would have to be 14. Then if E is equal to 14, then F has to be 6, which is not possible because the minimum value possible is 7. Hence B cannot be 7. Hence A has to be 7. Therefore, the values which we have finalized till now is A is equal to 7, B equal to 0, and C equal to 15. Now, let's consider line V2. On line V2, we have 0 already placed. Now, since E is the second largest variable, both E and Y can take these values only. Also, the minimum has to be more than 7. So E can be 11. In that case, Y would be 10. If E is equal to 12, then Y has to be 9. If E is equal to 13, Y has to be 8. That's the only three possible set of values, because the sum has to be 21. And E has to be greater than Y. And Y has to be minimum 8. So only these three sets of values are possible. Now let's look at each of these values. If I make E equal to 13, then D or F, they have to be 7, which is not possible because 7, we have distinct integers and A is already 7. So D or F cannot be 7. Hence, E cannot be 13. If we make E 11, then D, F has to be 9, or D plus F has to be 9, which again is not possible because if D equal to 9, then sum of V1 would exceed 15. And if F equal to 9, the sum of D, C plus F here would become 9 and 15, 24. So 2 would be left out for V3. So Z cannot be 2. Again, breaking the minimum 7 rule. So D cannot be 11 as well. So the only possible value for E is 12. And if E is equal to 12, then Y will become 9. So now we have values of E and 9 as well. Now, if E is equal to 9, then F has to be 8, D has to be 8. But D cannot, F here cannot be 8, because if F equal to 8, then Z has to be, leftovers of 15 plus 8, which is only 3. So, which is not possible. Hence, D has to be 8. If D has to be 8, then F has to be 0, and X has to be 0 as well, and Z has to be 11. So, if we place all these integers, we have this particular solution with us, which is a possible solution. All the values, they are, they actually filter out, they actually fit into all the rules that we have possible. So this is a possible solution that we have in the first scenario where C is equal to 15. Now, let's consider the next second scenario where A is equal to 15. So if A is equal to 15, then D and X both have to be 0 here because the sum of line V1 is 15. Then on line RA, again, similar to scenario 1, B cannot be 15 because if B is equal to 15, then E or Y has to be 14 and correspondingly F and Z cannot be 6. Hence, because minimum is 7. Hence, B cannot be 7. Hence, we'll have B equal to 0 again and C equal to 7. So we have placed the values, all the values for D, X, B and C in this case. Now let's consider the line V3. So on line V3, F and Z, they have to total up to 19 because 7 is, C is already 7. So F plus Z has to be 19. So the possible values are 10 and 9, 9 and 10, 11 and 8, and 8 and 11 because both of them cannot be less than 7 or equal to 7 also. So in this case, these are the only 4 possible values that we have. If I make F equal to 10, then E will also be equal to 10, which is not possible because the integers are distinct. Again, if F equal to 9, then Y and Z will come out to be 10 and E would come out to be 11, which is also not possible because distinct integers. If F equal to 11, then E would be equal to 9, which is also not possible because E is the second largest number that we have. So that's also not possible. So the only scenario possible is F equal to 8, then E would come out to be 12, Y would come out to be 9, and Z would come out to be 11. So this is the only possible solution that we have. So if we now place all the solutions here, we have this possible solution in scenario 2. So we have two possible solutions. One where E is equal to 15 and second where C is equal to 15. Now let's look at the questions that we have. So the first question is regarding the intersection at RC and V2. RC and V2, this. So the equation, the variable Y. So Y is 9 in both the cases. So if you look at the options, the option B, right? The ATM placed at RC-V2 intersection has a cash requirement of 9 lakhs. That's the right answer because in both the scenarios, Y is a fixed variable with value 9. Let's look at the second question. How many ATMs have cash requirements of rupees 10 lakhs or more? So if we consider solution 1, there are 3 values more than 10, 15, 12 and 11. Also in solution 2, we have 3 values more than 10, 15, 12 and 11. So answer is 3. Next we have 2 statements and we want to see like whether statement A is true, B is true, neither is true or both are true. So statement A is RA, RB and RC has 2 ATMs each. Statement B is each of V1, V2, V3 has 2 ATMs. So in solution 1, we can see RA, RB and RC have 2 ATMs each and V1, V2, V3 also have 2 solutions each. So both the statements are true as per the solution 1. But if we consider solution 2, then V1, V2, V3, they don't have 2 ATMs each because V1 just has 1 ATM of 15 requirement. Hence, only RA, RB and RC have 2 ATMs each. That is something we can finalize over. So in this case, only statement A is true. So option A is the correct answer. Next we have is what can be said about the road distance between ATMs having second highest and second lowest cash requirements. So second highest is our point E, which is the center point, and second lowest is 8. So distance between 8 and 12 in first solution is 4, and distance between 8 and 12 in second solution is 7. So the answer would be either 4 or 7 kilometers. Option D. And the last question is, what is the number of ATMs whose location and cash requirements can be both uniquely determined. So if we consider the location, first ATM at point A, there we can see the location, the value is fine, but the location cannot be determined for 7 and 15. Hence, the only possible options for this is 12, 9, and 11. We'll not consider this 0 because there is no ATM there. So 12 ATM, we both know the value and the location is on the center. 9 is also fixed and 11 is also fixed. So only 3 of the ATMs are fixed in terms of location and the cash requirement. So the answer would be D. So that's all about this particular problem. Study hard, think smart, keep learning, keep practicing, and for more such solved problems, subscribe to this channel. Until then, stay motivated, stay focused. We'll be with you along with in another part of Wealthy Cat series soon. Thank you so much.